Hi, everyone. Thank you for joining us today for the first event of the Union of Concerned Scientists Summer Webinar Series on groundwater. My name is Adrienne Alvord, California and Western States Director for the Union of Concerned Scientists, and I'll be moderating the discussion today. Today's event is titled Sustainable Groundwater Act, New Requirements and Tools. We'll be hearing from 3 experts who will provide information on how the landscape on groundwater management has changed since the passage of new legislation in 2014. We hope that listeners will leave this discussion with an understanding of new publicly available tools so that we can utilize these to the best of our ability as we move forward in bettering our water management practices. We'll begin with some brief introductions, but before we do, I'll quickly go over the ReadyTalk software. Most of you will be viewing the presentation from your computer. It won't be necessary for you to dial in, as you'll be able to hear the speakers through the audio on your computer. However, if you are unable to access the sound at any point, the dial-in information is listed on the right below the title on the introduction slide. We encourage you to engage with our speakers. If you look to the left-hand side of your screen, you'll see a chat box where you can comment at any point during the presentation. This is also where you will be able to submit questions. Feel free to post questions here as they arise, and we will keep track of them so that our presenters will be able to address them during the Q&A. We will give 1 to 2 minutes after each presentation for any quick clarification questions, but those that will require longer responses will be held until everyone has gone after all 3 speakers have completed their talks. With that being said, I'll give a little background on today's speakers. Juliet Christian-Smith is a climate scientist with a climate and energy program at the Union of Concerned Scientists based in our Oakland office. Dr. Christian-Smith is the lead author of the book, A 21st Century U.S. Water Policy, and an editor of the journal Sustainability Science. The focus of her work is providing California and U.S. policymakers and the public with robust, timely, accessible, and policy-relevant information on climate science and climate impacts. Our second speaker, Stephen Springhorn, is a senior engineering geologist with the California Department of Water Resources in Sacramento. Stephen has over 10 years' experience working on a variety of legislatively mandated programs and projects, including the Sustainable Groundwater Management Act, the Integrated Regional Water Management, Technical Assistance and Grant Administration, and evaluation of stream depletion impacts of groundwater, and substitution, transfer, and conjunctive use programs. Stephen has an MS in Geology from CSU Sacramento and a BS in Geology from CSU Chico, and is a California professional geologist. Our third speaker is Stephen Phillips. He's been a hydrologist with the U.S. Geological Survey in California for 30 years. His primary experience and interests involve using simulation models to better understand hydrologic systems and developing tools to manage these systems. Most of his career has been spent addressing issues related to irrigated agriculture, artificial recharge, land subsidence, and associated water supply issues in the San Joaquin and Antelope Valleys of California. Before we move forward, I have a couple of poll questions to those participating in today's event. These will give our speakers a better understanding of our audience. The first is, how would you describe your interest in groundwater? And the second question is, how much do you know about the Sustainable Groundwater Management Act? Great, thank you. Now we're ready to begin the presentations, and we'll begin with Juliet.
All right, thanks everybody. My name is Juliet Christian-Smith, and I'm a climate scientist here at the Union of Concerned Scientists. And I work at the intersection of water and climate change. I've been interested in water ever since I was a child, where I spent summers on an island off the coast of Maine with no running water. And so the value of water became very clear to me and informed a lifelong study of the science and policy of water management. As we all know, California is in the 4th year of an exceptional drought. When surface water supplies are scarce, we turn to groundwater. Unfortunately, our combined groundwater uses have led to chronic overdraft in many cases. Like a bank account, overdraft means we are withdrawing more than we are replacing. Together, this, exceptional drought, along with the undesirable condition of many of our groundwater basins, led to significant policy change last year, the passage of the Sustainable Groundwater Management Act. And today we're going to focus on the new requirements of the Act and some of the tools you can use to better understand your groundwater basin and tools that can help local management entities comply with the Act and thus avoid state intervention. So what's new? Essentially, this cartoon boils down the nearly 50-page Act into one slide. And you can see that the folks in the car are listening to their global positioning system tell them that they have arrived at the most exciting destination of your life, which as you can see is straight off the edge of a cliff. In many ways, groundwater management up until this point has been a bit like this. A lot of nice sounding objectives, but not specific enough to avoid driving many groundwater tables off a cliff. And the tagline at the bottom reads, "Why you need to be specific with a GPS." Similarly, in order to sustainably manage groundwater, it is important to be specific. And the Sustainable Groundwater Management Act requires for the first time that all at-risk groundwater basins use measurable objectives to achieve sustainable yield and avoid undesirable results. Those kinds of undesirable results are land subsidence, seawater intrusion, chronic lowering of groundwater tables. One way of thinking about this is that a groundwater plan now has to give the specific coordinates of where it is headed. And if those coordinates are off, or they look like they might drive a basin off a cliff, the state can take the wheel. And so there are a lot of different components of what's new, from new institutions to new plans, new tools and data, new goals, and new players. But certainly not least among these is new consequences. Both the Department of Water Resources and the State Water Resources Control Board may intervene if locals are not able to form a groundwater sustainability agency or fail to adopt an adequate groundwater sustainability plan. And that is certainly quite different than the past. Today, we only have time to talk about the first three: new institutions, new plans, and new tools and data. We hope that you'll join us in July and August for our next two webinars on the new players, all of the interests that will need to be involved, and the new goals, specifically setting measurable objectives to achieve sustainable yield. Today, my role here is to set the stage for the next two presenters by quickly reviewing the timeline of the Sustainable Groundwater Management Act. And then I'll provide an overview of the three items that we're discussing. First, the new institutions that are called Groundwater Sustainability Agencies, or GSAs. Secondly, the new plans that the Act requires, Groundwater Sustainability Plans, or GSPs. And thirdly, I'll introduce several of the publicly available tools and data sets that the other presenters will be explaining in much more detail. So the timeline of the Sustainable Groundwater Management Act. It went into force this January 2015, and by June 2017, the Act requires the formation of local groundwater sustainability agencies. Next, in 2020, once those GSAs form, they have several years to put together a groundwater sustainability plan. And finally, they have 20 years to fully implement that Sustainable Groundwater Plan and achieve the sustainability goal for the basin. Although the timeline goes out to 2040, every 5 years GSAs must submit reports that show how they are on track to meet their interim milestones. Additionally, every year GSAs are required to report on some basic information such as groundwater levels and total aggregate groundwater pumping and change in groundwater storage. So starting back at the beginning, what many people are focused on at the moment is putting together a groundwater sustainability agency for their area. The law states that any local agency or combination of local agencies overlying a groundwater basin may elect to be a groundwater sustainability agency. Eligible local agencies include everything from incorporated cities, counties, municipal water districts, irrigation districts, water conservation districts, public utility districts, community service districts, county drainage district, or even an investor-owned water utility that's regulated by the Public Utilities Commission, only if in the GSA the local agencies so allow. It's important to note that in the event that there is an area in the basin that is not covered by a groundwater sustainability agency, the county will be presumed to be the GSA. You can see here, this is a map of a groundwater management district outlined in orange. And that area does not line up exactly with the basin, which is outlined in blue. In this area, there are parts of the basin that are not covered and would be considered a white area, or an area outside of the jurisdiction of a GSA that would then become the management responsibility of a county, unless they chose to pursue a basin boundary adjustment or make another allowance. The GSAs are tasked with considering the interests of all beneficial uses and users of groundwater. And they are also required to coordinate with local land use planning entities and general plans. The legislation is clear that an array of interested parties must be included in the formation of GSAs. And these interested parties include, but are not limited to, agricultural users, domestic well owners, municipal well operators, public water systems, environmental users, surface water users, and California Native American tribes, as well as disadvantaged communities. When a GSA is formed and submits its paperwork to DWR, it is required to submit a list of interested parties and an explanation of how their interests will be considered in the development and operation of the GSA. There are also numerous requirements for public notice throughout the Act. GSAs have wide-ranging authorities, from conducting investigations to determine the need for groundwater management and to monitor compliance, to requiring registration and measurement of groundwater extraction facilities, to levying taxes and fees pursuant to the same rules for municipal ad valorem taxes. While it's clear that GSAs may take on broad authority, they very well may not choose to use that authority. Next, the GSAs must put together groundwater sustainability plans. And groundwater sustainability planning is not new in California. Over the last 2 decades, more than 100 local groundwater management plans have been adopted under the provisions of 2 laws, Assembly Bill 3030 and Senate Bill 1938. However, those plans were voluntary, unenforceable by the state, and tended to have fairly broad qualitative goals. So these goals were called basin management objectives. And examples of basin management objectives include improved water quality and more sustainable groundwater use. While these are useful goals, they're not specific enough to clearly define when and where actions are necessary. The new groundwater sustainability plan requirements ask for much more specific measurable objectives and interim milestones. We suggest that these should have quantitative thresholds for what improvement and sustainability look like, and interim milestones provide a map that can show how a basin will get to its desired destination and how long it will take to get there. Old plans can be a good starting point. This is the typical triangle, starting with groundwater management that defines broad management objectives and some possible management actions and stakeholder involvement and monitoring that might be necessary. New groundwater sustainability plans can use similar types of information, but need to require specific measurable objectives and thresholds to determine when those objectives will be met, and mechanisms for triggering action to ensure that those thresholds are not exceeded. So for example, a broad goal may be to achieve sustainable management or sustainable yield. A more specific basin management objective may be to reduce unsustainable overdraft. A specific measurable objective could be to reduce groundwater extraction by 150,000 acre-feet per year. And this might involve a variety of different management actions that occur at different times in different places, such as limiting groundwater pumping during a dry season, And it will obviously also involve working with stakeholders. A monitoring program may require that the GSA collect information about groundwater extraction and work with stakeholders to provide outreach to well owners and municipal users. So today we're going to learn about some of the new tools and data that groundwater managers and groundwater users have at their disposal to think about how groundwater entities can comply with the new Sustainable Groundwater Management Act. The Department of Water Resources will discuss a variety of mapping tools that they have available and groundwater level and quality data that they have been collecting. The U.S. Geological Survey will be presenting on its experience with groundwater modeling and monitoring and modeling tools that they provided to water districts throughout California. In conclusion, the new law basically requires that groundwater basins have a plan for where they're headed. And this plan has to be specific enough so that everyone can understand how you'll get there, the speed you are going, and when you will arrive. It seems basic, of course, but we all know that groundwater is a complicated resource, made more complicated by the fact that people can't actually see it, and therefore it can be difficult to realize when we're headed off a cliff and to change course. As climate change warms California, we're projected to lose up to 80% of our historic snowpack, and this year is truly a bellwether of what is to come. Sustainable groundwater management is key to allowing us to adapt to a massive shift and loss of surface water storage. And it's critical to the future of this great state and to the choices that will be available to our children. I will pass it over now to Stephen Springhorn from the Department of Water Resources.
Thank you, Juliet, and thank you to the Union of Concerned Scientists for the opportunity to speak today, and thank you for everyone who's tuned in. My name is Stephen Springhorn from the Department of Water Resources, and today I'd like to give a tour of the groundwater tools and technical assistance that the Department can provide GSAs as they develop their groundwater sustainability plans, and also for the public to get a better understanding of groundwater in the state. So the Department has a long history of collecting and analyzing groundwater data, investigating and reporting groundwater conditions, implementing local groundwater assistance grants, and encouraging integrated water management. So all of those tools are providing technical assistance needed to improve statewide groundwater management practices. So DWR has been investigating groundwater for many decades, and the importance of groundwater has been known all the way back to 1957. Our director stated that groundwater is an important component to California's water picture, and at that time he quoted, there are seriously lacking data and information necessary to plan for the use of groundwater. So with the drought and the enactment of SGMA, there's now a new focus and soon to be a new standard of groundwater management in the state. And that's reflected in the quote from the current director of DWR, Mark Cowan, that today it is all the more apparent that the need to change the trajectory in terms of our ability to understand groundwater and take bold actions to manage it sustainably. So those are the key points. And I'll be describing now the tools that we have been providing and ask for input on potential tools that we could provide in the future to achieve these goals. So the main website that the department hosts on groundwater is in front of you here, and it has a number of key components. The first is the Sustainable Groundwater Management Program, as Juliet mentioned earlier. It also has the Groundwater Information Center. This site has groundwater basics, technical information, maps, reports, that kind of thing. And then another component is the CASGEM program and Water Data Library. Think of these as the DWR groundwater databases where the raw data resides that we can use to analyze the groundwater analysis. And finally, Bulletin 118 and Bulletin 160 are the comprehensive reports that the department is required to publish on groundwater and the overall California Water Plan. So I'd like to go into detail on each one of these components, and I'd like to share my desktop. However, it doesn't look like I'm able to, but that's fine. So the Sustainable Groundwater Management website has an introduction, announcements. This is where all new information gets posted. And then on the right-hand bar is the information pertaining to all the major milestones and projects and activities the department is doing related to the Sustainable Groundwater Management Act. So basin boundary regulations, GSA formation, and GSA notifications with a searchable table of all the GSA notifications the department has received. And we're working on a map to show the boundaries of GSAs, as well as groundwater sustainability plan regulations, our communication and outreach program, and resources. So one of the resources I would like to highlight is our water management planning tool. This is an interactive map that displays a number of boundaries, water management boundaries in the state, counties, where department regional service areas are, tribal lands, disadvantaged communities, basin priorities, and groundwater basin boundaries. And when you click in each one of these polygons, information pops up, and it's a live link or direct link to that information. For instance, Juliet mentioned GMPs or groundwater management plans. We have a layer on this map that you can turn on, and you can click in the polygon of that management area and get a direct link to that management plan. So the department has been trying to go from paper reports to more interactive and online content that makes it easier for not only GSAs but the public in general to get at groundwater information and to have a better understanding of the data available. So the next component is the Groundwater Information Center. This is a critical component of DWR's groundwater data. It has groundwater basics, maps and reports, groundwater management, the groundwater management plans, links to our databases, CASGEM, Water Data Library, and other critical components and useful information on this website. So another interesting tool, interactive map tool, that we have on this site is a GIS map interface or interactive map that displays groundwater level information. This shows groundwater level information, depth below ground surface, groundwater elevation, and then change in groundwater levels at various time periods, with the most recent data that is loaded is spring 2014. And there'll be spring 2015 loaded onto this map shortly. And so a zoomed in version shows you can overlay a number of the boundaries that I mentioned earlier with the groundwater level information to see how those boundaries and the management in those boundaries are reflected in the groundwater levels. The next map or interactive map is a portion of the same Groundwater Information Center interactive map, and it's based on land subsidence or has land subsidence information. Again, there's interactive layers where you can click in the map, get information, and click on actual dots or stations here and get a live feed of subsidence trends from continuous GPS stations, the department's extensometers, and other subsidence-related information. The next component is CASGEM, the California Statewide Groundwater Elevation Monitoring Program, and our Water Data Library. Again, as I mentioned earlier, this is really where all the raw data is stored and hosted for not only the department to analyze groundwater information, but for any other interested entities to use this information for groundwater studies. So here's a screenshot of the CASGEM interactive map. This is the purple dots show CASGEM monitoring wells with information, CASGEM well, total depth, who monitors it, and you can get hydrographs for all this information. This is the newer database for groundwater elevation monitoring that was enacted in 2009, and data started streaming in to this system in 2011. For older or historical data, the Water Data Library is another very useful tool to show all of the other groundwater elevation data in the state, as well as water quality. And this has the department's continuous dedicated monitoring wells information for those are on this site as well. The next component is Bulletin 118 and Bulletin 160. Bulletin 118 is the department's report on groundwater. It has not been updated since 2003, although the department plans to update this in 2017 and then a comprehensive update in 2020. And I start in that direction with the recent release of the California Water Plan information on groundwater, and that has had a substantial increase in the amount of information available on groundwater in the groundwater basins throughout the state. There are three main components of the Water Plan Update 2013. One is to improve statewide and regional understanding of groundwater conditions and management, identify data gaps in groundwater management challenges, and then development of recommendations to improve groundwater management in California. So that information is available at the following link, and there are webinars that are occurring this summer, and the next webinar will be in the July timeframe, talking about the detailed information, the groundwater level information, or groundwater information in general that's coming out of this report. So you can sign up for the listserv to get that information, and at this website here is a list of recording of previous webinars on the California Water Plan. Just some examples of what is in the water plan. There is a lot of new groundwater data. The data ends in 2010, but it's statewide information, so depth to groundwater, groundwater elevation, as well as change in groundwater elevation from 2005 to 2010. So with that, I'd just like to close and thank everyone for your attention and pose an open question. And the department is always interested in providing tools and providing technical assistance that will promote sustainable groundwater management and will lead to a better understanding of groundwater. So if you have any questions or comments on this question or the presentation, please email me, and thank you very much.
Thank you, Stephen Springhorn. And now we'll hear from Stephen Phillips from the U.S. Geological Survey. Stephen Phillips?
Oh, I
Yep,
think
sorry. I was on mute. I was talking away.
Can you go back to the first slide?
Yes, I'll go right back. I'm Steve Phillips. I'm from the California Water Science Center of the U.S. Geological Survey. We have main offices in Sacramento and San Diego and 8 field offices throughout the state. And we do a lot of work in groundwater in California. So today I'm going to show you a snapshot and a number of the tools that we've developed to work with water districts and other cooperators that are relevant to sustainable groundwater management. Okay, and of course for monitoring, groundwater levels and quality are a big part of it. And this is an example from the Mojave Water Agency, where initially we helped them set up an extensive well network. It covers a large area in Southern California. You can see here, it's a big part of the Mojave Desert. And so we initially helped them a lot with this network, but now Mojave Water Agency does almost all their own monitoring. One thing we continue to do is to host an interactive website where you can see hydrographs, and that's a snapshot shown here, showing hydrographs of key wells around the basin over time. You can also see contour maps of groundwater levels. An interactive portion is looking at change maps. You can look at beginning year, ending year. It generates a change map of water levels that you can then look at and explore. Also, Lancet science data are up on there too, using satellite methods, which I'll show you next. I don't have time to show you the website, but I included the link there below if you want to take a look. Okay, speaking of Lancet science, one key, new, and pretty powerful way of monitoring it is to use what we call INSAR. It's interferometric synthetic aperture radar, which is why we call it INSAR, a lot easier to say. And this is an example from northern San Joaquin Valley, where we're currently seeing about a foot per year maximum in this area here. And just to give you a feel, this green area out here and out here, you're not seeing much change, but everything within the purple and blue is going down, and going down at a pretty rapid rate. You're seeing about a foot per year here. Here along the San Joaquin River, you're seeing about a half foot per year. And this foot per year is occurring right along this major flood control channel. So it's not a good thing. And these high rates are continuing during the drought. So the tool here is called INSAR. The big advantage of it is it's broad coverage, as you can see on this map, and also it's high precision, which is about centimeter level. And you can couple it with other tools, and it's a very effective method for monitoring land subsidence. Another thing that is relatively difficult to monitor is stream flow depletion, the effect of changing groundwater levels on stream flow. And one way that we've been using to do that is to use temperature measurements in combination with water level measurements, both in the surface water and in the groundwater. What's shown here is say an existing surface water gauging station, where we then add wells, often on either bank, and measure water levels and temperature in those wells and in the surface water. And when you look at that data, you can then get a real good sense of what that groundwater surface water change is over time, and in fact instantaneously, essentially, if you send it as shown here via satellite to a database. Also on the monitoring side, seawater intrusion. There's a tool called electromagnetic tool, Bohr Electromagnetic Survey, or EM, which is literally a tool you put down a well. It has to be a PVC well. It can't be metal. When you do that, you get a signal back, and that signal reflects how easily electricity is conducted in materials around the well. So you send it down the first time, and it reflects the materials down there, whether it's sand, clay, gravel, and also the water, the conductivity of the water, which depends on its salinity. So, for example, here's one of these surveys going down to 1,600 feet in a well, and it's showing a relatively small electromagnetic signal, and the chloride concentration is relatively low, compared to here, where you see a very strong EM signal, and the chloride concentration is quite high. So you can essentially use this this EM tool as a proxy for chloride in this case, which is a good indicator for seawater intrusion. And it has multiple advantages. One, you don't have to send so many samples to the lab all the time. But probably even the bigger advantage is you can see exactly where these increases are occurring down your borehole, and that can help a lot when you're trying to figure out how to manage water levels in your well, how to put in new wells to avoid the problem areas, etc. And one nice thing is you can use this EM tool, this EM method for areas not having anything to do with seawater intrusion as well. You can essentially use it as a TDS indicator or tie it to concentrations of nitrate or other key indicators of concern. Let's move into modeling for helping with basin understanding and looking at management options. This is a map showing existing USGS groundwater models in California. So there are a number of them. We've done a lot of basins over time, and each one has a variety of different features and periods that are simulated. We're looking at modeling for stream flow depletion. This is specifically in Santa Rosa Plain, working with Sonoma County Water Agency. The tool is GS-Flow, which is a way of coupling a surface water model, it's called PRMS, and a groundwater model called ModFlow. Those are coupled together in this tool called GS-Flow, which is really powerful for looking at the connection between streams and the aquifer, and was used in this case to look at various future scenarios and possible future outcomes and what the effect on various streams would be for those various futures. Modeling is also great for looking at water budget analysis, and that's when it comes down to sustainability, that's really what it comes down to, is getting your water budget on the zero or positive side. And this example is work we did with the Pajaro Valley Water Management Agency. Pajaro is along the Monterey Bay coast, and they have considerable pumping inland, both city and agricultural pumping, that has caused water levels to go down quite a bit below sea level, and they have seawater intrusion. So it's really important for them to even out their budget and in fact get it positive some to help push that seawater out. And they've taken a number of steps to do that, and they're not quite there, but this with the modeling we did with them, really helped to look at exactly what that number is, so they have a number to shoot for in the future to achieve sustainability. Modeling is also great for looking at water management strategies. You can try a whole host of different management options without having to put a shovel in the ground to give a feel for what might be the best bang for the buck. And this example is in Antelope Valley, where they looked at, and this is one of many examples that we looked at for Antelope Valley, but this was redistributing the pumping from key areas where you're seeing a lot of drawdown, moving it to other areas that aren't seeing as much drawdown and piping the water over. So you can look at all sorts of things: redistribution, pumping, managed aquifer recharge, water conservation, alternative water sources, and many other water management strategies to see what might work in your basin without having to put in the infrastructure to find out. Also important is the effects of climate change on runoff and recharge, and modeling is also a great way to look at that. One of the tools we use a lot here in California is the Basin Characteristics Model, or the BCM. It simulates all of California on a 270-meter scale, so very small pixels. It has information on the geology, the soils, the snowpack. It simulates the growth and melting of the snowpack includes, of course, evapotranspiration and all sorts of other processes that are important to runoff and ultimately recharge. That includes 18 downscaled climate scenarios from global climate models. So shown over on the right, there are the various watersheds that feed into the Central Valley. So the BCM is run in these areas and estimates the runoff that comes into each of these streams along the margin of the groundwater basin, and then also estimates ultimately the recharge associated with those streams and with direct precipitation under the valley floor. So it's an important tool for understanding something that's difficult to quantify, that being recharge. We also use modeling to look at seawater intrusion. This is an example of Santa Barbara, where they're seeing this contour here is 90 feet below sea level, and you get up to the coast and it's more than 10 feet below sea level. So they have a problem, and we're helping them. By modeling this, we're helping them come up with various management alternatives that will work best for dealing with that problem. And the tool we're using is a new model, relatively new model called CWAT, that allows you to simulate variable density flow and transport. So you get a really good simulation of the freshwater seawater interface, which is never a straight line because of the different density of the two waters. And you can look at transport of chloride, for example, which is a good indicator of seawater intrusion. And finally, I want to show you an example of modeling with respect to groundwater quality. It's a relatively difficult nut to crack sometimes, and in fact, even monitoring groundwater quality can be expensive and difficult. So this is a tool that we developed in California. It's actually a suite of tools for, first of all, measuring borehole flow, wellbore flow. So here's a well, for example. This blue part is showing where water is coming into the well. This is percentage by percentage. So you see an increase like this. A lot of the water is coming in the well there, for example, and not much here. And there's where essentially the rest of the water is coming into the well. This was run over a few years, and you see a similar pattern, but changing over time. Partly because the water level in the area has changed as well. So you know where the water is coming into the well. At the same time, you do depth-dependent measurements of chloride or whatever constituents of concern you have, and you see the profile of where chloride is in the well, which is really important to know the combination of where water is coming in the well and what water quality is associated with that. And that's really powerful when you're looking at how to manage this well. For example, you could use this to in combination with wellbore flow modeling. We've got a spreadsheet tool called Analyze Whole. So in combination with this data, you can plug in various pumping rates and estimate what that chloride concentration will be coming out of the well, and where it crosses the MCL or any drinking water standard you're interested in. That's where you could set a threshold, as Juliet was mentioning earlier. So it's a pretty powerful tool. Sorry I had to go through these really quickly, but if you have questions, here's my contact information, and I can help you understand better. Thank you.
Thanks, everyone. The participants can feel free to enter in questions in the chat box, and we have one already from Kristen Carter. She writes that they have a group of groundwater users that would like to organize. This is a group of concerned citizens, and what can your organizations do to support us? Maybe I'll start with Stephen.
Yeah, thank you for the email, for the question. So one way to get involved is through this new GSA process, where the GSAs, or the Groundwater Sustainability Agencies, are required to consult any interested parties or uses or users of beneficial or of water. So that's where you can get involved in the new SIGMA process. There's also integrated regional water management that the department has a long history of promoting and working on. And there are more avenues for stakeholder involvement or interested persons to get involved in the IRWN arena too. So if you wanted to email me, I could point you in the direction of those programs I mentioned, but that would be the place to start.
As far as USGS, certainly contact us. We can let you know what work has been done in your area. Certainly we provide data. All our tools are publicly available for free. So very happy to help along those lines and to discuss your situation.
Yeah, and thanks, Steve. That reminded me of another useful tool, and that would be contacting our region office staff. So wherever the group of groundwater users resides, there's a DWR region office that represents you, and there are geologists and engineers that have a lot of local knowledge of the groundwater as well as DWR programs. So that would be another place to get more information, is the DWR regional office in your area.
We have another question, which is, how does DWR control the quality of raw data submitted to CASGEM?
Another good question. So CASGEM is a voluntary program, and that's how it was enacted. And CASGEM is based on the monitoring entity. So a monitoring entity is the group that is a local agency or another group that monitors the area. And they have to submit a monitoring plan for their area that is approved or has been approved. And so in those plans, those monitoring plans for their areas, there's information on how they collect the groundwater level information. And so that's one way, is that we review the monitoring plans. However, when they submit, there are a few QA/QC steps that we can track any erroneous information that's submitted, although it is a little limited. So it can be an issue sometimes when we're doing regional or statewide reports. That's where we work with our regional office staff as well.
There was another question regarding getting everyone's contact information, and there will be a follow-up email that's sent out after the event to everyone with information and maybe the slides. Another question is, how long does it take to do this type of modeling? I think this question goes to Steve.
Well, it depends. Some of the simpler modeling, like I mentioned, using analyze whole on that last slide to look at water quality, for example, that could be a day or two. Fully 3D, looking at an entire basin, groundwater flow, groundwater surface water interactions, that's looking more like a year plus, depending on how much data is already available. But the big giant flow models are time consuming to put together. The good thing is that they're what we call data integrators. They put all the data into one place and help you better understand what's happening in the system, and enable you to look at management options in the future, assuming various climates and other future conditions. So, but yeah, the cost and time allowed are quite variable.
Thanks. There's another question from Kristen. Do any entities track if a well goes dry? Is there public information about the number of wells that have gone dry in a certain region?
Yeah, I can take that one. So there is a lot of useful information on the department's website, and the most recent drought report that has actually information on, if I can go back to my slides, on wells that have gone dry or that have been reported to the department. And so that would be on the Groundwater Information Center. Sorry for... And again, the region office staff would be the personnel to contact if your well is going dry, or if you want to inquiry about other wells going dry in the area. And then some local agencies also have hotlines. I've seen a county hotline and other local agencies that provide resources for interested persons for that type of information.
And, sorry, go ahead.
Are there any more questions?
One more question about how this information is acquired. And I assume this is referring to wells going dry.
I would have to defer to what is in the most recent drought report for that information. I don't know exactly how the information was acquired, but it's reported on in the drought report, which is on the Groundwater Information Center.
Also stay tuned for possible changes to the access to well log information. The budget that was passed last week included allowing public access to well logs. But there are still some pieces of legislation that may negate that. So that's another possible avenue to keep track of. Is there a way to accelerate, this will be the last question from Karine Mandelbaum, is there a way to accelerate the interim measures to achieve sustainability for those basins that are high priority?
I can take that one. Well, we are working very hard to get the rules in place for basin boundary regulations, as well as the Groundwater Sustainability Agency, plan regulations. So those would be the new rules for groundwater management or sustainable groundwater management in the state. And until those rules are in place, there's existing management that needs to be done, and that management can happen under the existing groundwater management plans that are out there. So it really is, we're working as fast as we can to get the groundwater sustainability plan regulations in place.
Okay. I think that wraps up our events and discussion for today. We hope that you found this informative and helpful as we move forward to implement the Sustainable Groundwater Management Act. Today's event was recorded so that we'll be able to share the information after we conclude today, and we'll share it with you so that you may circulate it to your networks. We'd also like to remind you that our next UCS event, titled A Roadmap to Stakeholder Engagement in the Sustainable Groundwater Act, will be taking place on Wednesday, July 15th at 10 a.m. If you haven't already RSVP'd for the event, we hope that you will do so soon, and we look forward to hearing from you again. Thank you again to all of our speakers, and thank you all for joining us today.
This does conclude today's conference. You may now disconnect.